Sunscreen, clothing, and caves may have given modern humans an edge over Neanderthals when Earth's magnetic field wandered. A new study suggests the extinction of Neanderthals nearly coincided with a shift in Earth's magnetic field that let more radiation reach the ground. Our species might have adapted more easily. One of the most enduring questions in anthropology is why Neanderthals, our closest extinct human relatives, completely disappeared around 40,000 years ago. Possible theories include climate change, resource competition, and the dilution of Neanderthals' genes through interbreeding with modern humans' ancestors. Now, new research suggests early Homo sapiens may have had an edge on their cousins thanks to their use of sun protection, namely natural sunscreen, tailored clothes, and caves, during a period of unusually strong solar and cosmic radiation. The research is detailed in a study published last week in the journal Science Advances. Earth's moving interior generates our planet's magnetic field, an invisible shield that helps protect us and our atmosphere from harmful energy coming from space. This magnetic field has a north and south orientation, which currently roughly aligns with Earth's north and south poles. Those are the sites where the field is the strongest, which is why auroras are usually visible at more extreme latitudes. Sometimes, however, the magnetic field's poles wander from the planet's geographic poles in what scientists call geomagnetic excursions, according to a statement. Occasionally, the magnetic field's north and south poles swap completely, a natural phenomenon that has taken place about 180 times in Earth's history. The most recent geomagnetic excursion, called the Lachamps excursion, occurred around 41,000 years ago, just before Neanderthals went extinct. To investigate this event for the new study, an international team of researchers reconstructed Earth's upper atmosphere and nearby space during the Lachamps excursion, using a 3D computer model. By combining this with models of the space plasma around Earth and our planet's auroras, the team suggests that during the Lachamps excursion, Earth's magnetic field overall was only 10% as strong as its current level. This allowed the North Magnetic Pole to wander over Europe, making aurora visible across the continent. It also let more cosmic radiation reach the ground. During the Lachamps event, the magnetic poles shifted away from true north. Lead author Agni Mukhopadhyay, a climate and space scientist at the University of Michigan, tells BBC Science Focus's Hattie Wilmoth. This movement, coupled with a notable weakening of the magnetic field, resulted in an expanded auroral zone and increased atmospheric penetration by energetic particles, such as solar energetic particles and cosmic radiation. Both of those particles represent ionizing radiation, which can be harmful to human health. Interestingly, the Lachamps excursion coincided with notable developments for our ancestors and early relatives. According to the statement, some evidence suggests Homo sapiens started producing custom clothing, spending more time in caves, and increasing their use of a mineral called ochre at that time. There have been some experimental tests that show it has sunscreen-like properties. It's a pretty effective sunscreen, and there are also ethnographic populations that have used it primarily for that purpose. Raven Garvey, a co-author of the study and an anthropologist at the University of Michigan, says in the statement, "So, while archaeologists cannot directly observe the behaviors of people who lived over 40,000 years ago, we can hypothesize that the increased use of ochre may have been in part for its sun-protective properties," Garvey adds to BBC Science Focus. Environmental changes caused by the weaker magnetic field may have driven adaptive behaviors in human populations, such as the increased use of protective clothing and ochre for UV shielding, as Mukhopadhyay tells New Scientist's James Woodford. But as early modern humans made these lifestyle changes, Neanderthals ultimately disappeared. The team speculates these differences may have contributed to Homo sapiens outliving Neanderthals, who don't seem to be associated with the same developments. Not everyone agrees, however. There's definitely a rough overlap in terms of timing between the incursion of ancient modern humans into Europe and the Lachamps excursion, says Amy Mozig-Way, an archaeologist from the Australian Museum, who was not involved in the study, to New Scientist. But it's probably a stretch to say modern humans had better sun protection in the form of tailored clothing than Neanderthals, and that this contributed to their ability to travel farther than Neanderthals and their subsequent dominance of Eurasia. More broadly, the researchers suggest that our ancestors' survival of a severely weakened magnetic sphere could hold implications for how we continue our search for extraterrestrial beings. Many people say that a planet cannot sustain life without a strong magnetic field. Mukhopadhyay says in the statement, "Looking at prehistoric Earth, and especially at events like this, helps us study exoplanetary physics from a very different vantage point. Life did exist back then, but it was a little bit different than it is today."